Okay, now we're recording. So today's a fairly short day, but that's because the concept is fairly new, in the sense that you may not have done anything like it before. So I want to give y'all time to let it soak in before giving y'all something else. So we're going to start on page 12. Yep. Halfway through page 12 is where we'll start. Thank you. We're going to look at conditional probability. The way to think of conditional probability, just in a real simple example before we get into it, is like, let's say you're really hungry and you're in Walmart. What's the chance you're going to buy a bunch of food while you're there?
Bro, that's
pretty high, because you're there, you're hungry. Those chips look really good. I don't care that I have 3 bags at home. I'm hungry, I want them now. So you just start throwing stuff in your budget. Now, let's say you're really hungry, but you're not at a store. Would the probability be higher or lower that you stop somewhere to get something to eat? If you're just driving, you're not around the food, maybe lower. Unless you're just like, I'm hungry, we're stopping before I get hangry. But chances are, you could be hungry, but you're like, I'm going to go home, so I don't have to spend my money. I'll just eat mom and dad's food. And that's kind of conditional probability. Your situation determines the probability of something occurring. Turned on this time. Let's see here. There we go. So let's look at a motion sickness example. A study was performed to look at the relationship between motion sickness and seat position in a bus. The following table summarizes the data. So this table is saying, for instance, that 58 sat in the front and felt nauseous. 870 sat in the front and did not feel nauseous. So that's what that table's saying. So if we use, instead of writing the word out, because let's be honest, who wants to write whole words? If you can write 2 letters or 1 letter and have it work. The small c up here, that's the complement. So it means like not, if N was nausea, the complement of being nauseous would be not nauseous. Another way you may see this is like a hyphen right here. Instead of a C, just a hyphen. That means it's the complement. That's, we use C because C's, yeah. Yeah. Wait, did I say hyphen? Not a hyphen. Apostrophe. That's the reason I'm a math teacher, not an English teacher. Okay, so in our case, we'll use the C. You'll credit on y'all's assignments, I think they use the apostrophe. Yeah. Usually, like when I was in college, we would use the apostrophe. We didn't really use the C much. Okay, so we're going to shorten these to symbols. When I do it on the next, when we get to the point, I'll use the symbols. I won't write out the full words. Okay, so let's compute the probability that an individual was nauseous. So how many total people ended up nauseous? Well, there's nausea. How many, if we look at the total of nausea? 417. So to get the probability of getting nausea, it'd be 417 over 3256. That's the probability of getting nausea. 417 over 3256.
Are you supposed to write that total chart?
Probably wouldn't hurt. Basically, the chart is in your notes. It just doesn't have the total row or column. So you may want to add it. That's up to you, though. We'll be using the totals quite a bit, so you'll probably want it. I'll give y'all a second to get that written down and then get the totals in there while yes.
Just generally, when we're doing probability, what do you want us to round to?
Try to go to 4 decimal places. That eliminates any rounding error like further. If we went further into a problem, if you do 4, then let's say your final answer you round to 2 or 3. You're going one further while you're working it, so the rounding error won't be as large. Okay, let me take a screenshot of this table. Okay, so we found the probability of being nauseous by doing what? That's right, so the probability of nauseous, we said it was 417 over 3256. Which, to 4 decimal places, what did that get us?
1281.
1281. Okay. Yeah. Okay, so now that's great. We could do that. Honestly, if it were me, I'd probably leave the table like that. But that's not what they want you to know how to take it one step further. So we could calculate other probabilities real easily by dividing all numbers in this table by our total. So I'm going to draw, basically I'm going to draw y'all second table is what I'm going to do. So I don't have to actually draw the table because it's given. I'm just recreating it. Y'all don't have to draw one because I give y'all the blank table down below. Okay, this one isn't perfect, but let's just go with it. So let's see, we have front, middle, back, nausea, no nausea. Okay, so, and then this is our total. This is our total. What we want to do is we want to actually go through and figure out all these probabilities in this whole table. So we would divide in each block, divide that number by the total. So 58 divided by 3256 gives you the probability that someone sat in the front and was nauseous. So what is 58 divided by 3256? Yes. It's going to be a small decimal.
0.017.
0.0178. Yes. I drew my table too small, but oh well. And
What was that again?
We're looking at the relationship between motion sickness and seizure motion. So wouldn't it be better to divide nausea by no nausea to the probability sitting or and in each seat? So like 58 or 807, the probability of being motion sickness in the front seat.
I think you're on to something. We'll get to that here in a second. Okay. What was your question, Riley? Right now, what we're doing. Right. Or that's actually leading into conditional probability, which you were talking about. So we're getting. I see what you're saying. We're actually going to get to that point by the middle of page 13. We're building up to there. Right now, we're just calculating raw probabilities. So, what's the probability that they sat in the middle and were nauseous? 0.05. You're close. It'd be 10. If I remember right, it was 0.05098, right? This 8 tells me I need to round that 9 up, but when 9 goes up, this actually turns into a 10. Okay, then let's do back. So, back and nauseous. 0.0593. Okay, and if we add all these up, what would our total be?
0.1281.
Oh, where have I seen that number before? That's our probability of being nauseous. That we did before we even looked at this table. Okay, now let's go to the next row. So, not nauseous and front seat. 0.2672. Okay, middle and not nauseous. 0.3572. Back and not nauseous.
2475.
And I'll put up, once we fill in the table, I'll put up a nice neat version where my numbers aren't all squished together. Okay, so if I add this row up, what would I get? .8719. What if I add up this total column? What should I get? It would be 1 down here. So we could go through and total out these columns now. So for front, if we add these two together, it would be 0.2850. For middle,
$4.02.
4.082. And then last but not least, back. 0.3068. Okay, so I'm going to put up the nice neat table. That way, in case you couldn't see my squished together numbers, you could see this, hopefully. Okay, so let's talk about what each of these numbers exactly mean. Well, not what each of them mean, but just some of them. So, we already kind of figured out this 0.1281, sorry. That was our probability of being nauseous. Total for probability of nausea, 0.1281. But if we look at the columns, this down here is the probability of sitting in the front, that they sat in the front, so 0.2850. This is the probability that they were nauseous and in front. And then if we looked in the middle here, that's the probability of them not being nauseous and sitting in the middle. So that's what different probabilities on this table mean. Okay, so we set all this up because we'll need to use a table like this for conditional probability. So if E and F are two events where the probability of F is greater than 0, then the conditional probability of the event E, given that F has already occurred, is denoted by the probability of E given F. That's how you would read that. There's our formula. So the probability of E given F is equal to the probability of their intersection divided by the probability of the event that already occurred. This one, that's intersection, so and. So this is the probability of E and F. The other one is or. That's right. That was one of the things we talked about in 6.1. Yep. So if I would have recorded it, you would have heard me talking about in Word, Microsoft Word, or even just Microsoft period, even PowerPoint. If you insert equations, this symbol right here, they call it a cap. So if we're having an intersection, I just said, why you be capping? Okay, so this is our formula. Dual credit, I'm not sure if this is on your formula sheet or not. I can't remember. One of y'all have it handy, you can tell us, because I don't remember if it's the formula or not for conditional probability.
I don't know.
Not on there? Okay, then you probably need to memorize this one. This would be one you may want to memorize. And it's really, once we start using it, you'll come to realize it's really not that bad. Whatever two letters are here with the given symbol, you look for the intersection over the last one. That's all we're doing. Intersection over last. Okay, so let's go back to our nausea example. If we want to see if nausea is related to seat position, we might want to calculate the probability that a person got nausea given he or she sat in the front seat. Being in the front impacts our knowledge of the chance of them getting nausea. Is that what you were kind of getting at earlier? Yeah. We usually indicate such a conditional probability with the notation probability of nausea given front. So this probability of n given f is one of your blanks. That's how you read that. N given f, well, in our case, nausea stands for n, f stands for front. So we're told they're in the front. What's the probability they got nausea? Another way to think of conditional probability, which we'll get more into tomorrow, but just to kind of give y'all a teaser. Let's say we're drawing two cards out of a deck. If I draw one card and set it aside, does that affect my probability of drawing the next card?
Yeah.
Yeah.
You took one of the 52 cards out of the deck.
You took one of the 52 out of the deck, so that changes your probability. That would be a case of conditional probability. Whatever you get next is conditioned on what you got the first time. Okay, so back to our motion sickness deal. The event that a person got nausea, given he or she sat in the front seat, is an example of what is called conditional probability. So, of the 928 people who sat in front, 58 got nausea. So the probability that a person got nausea, given he or she sat in the front, is, let's set our formula up. So P of n given f. What would be our numerator? What would go on top? If we use the model that we talked about. So let's first just use symbols. So let's not plug in numbers yet. Let's use symbols. I don't think they. So probability of n given f, we can write that as the probability of n and f divided by the probability of f. So that's what I talked about. Just take the intersection of the two and then divide it by the last one. Intersection over last. Yes. Okay, so what's our probability of the intersection from our table? 0.0178. What's our probability of the front being in front? 0.2850. Good. Now they did it a little differently. Instead, they just went and said not 58 divided by 928, but they just used our raw numbers. However, you should still get the same answer. Whether you use the probabilities or you use raw numbers, you should still get the same answer. Questions on this example?
Where'd the 928 come from? Oh, wait, never mind, I see it. I had it written at the bottom. Thank you.
Okay, let's look at our next example. So in a survey of job satisfaction, the teachers are asked if they were satisfied or unsatisfied. And this table gives us the results of that. So if the cells are divided by the total number surveyed, 778, what table would we get? So I'm going to give y'all about 5 minutes. I want y'all to calculate the table like we did on the first one. I'm going to kind of let y'all lead this example because this is our only other example today. So we did one together. I want to see if y'all, how far y'all can get through this one. So I want y'all to convert y'all's table to probabilities.
Use our phone's calculator?
Sure. Or you can grab this one if it's quicker. You can use this one. Either way works. How are we doing on the table? Do we still need more time?
Yes.
Yes.
I just found the last number. It's a, one. You want to find out if it's not.
Right.
And then it's 6. And you round up. And you can say,
If you're done with your table, you can check your values. Oh.
and this way,
Which one? That's weird, is it? Yep, on total. What do you think? y'all want to just grab the total, maybe, if you still want to get practice working on it, maybe write them kind of down here or something. And then you can,
Yeah, I'm good on it's better, it's better to get it now.
and you struggle now than you struggle.
I'm not sure how to run math. I'll do that, I'll do it. I'll do math over there.
Okay. Okay. You know, when y'all got the totals, and then we'll go to the next part.
Okay, I'm good.
You good? How's y'all do on the totals?
Good.
Got them? Okay. Next. So, for convenience, let's say C stands for the event that the teacher teaches college. S stands for satisfied. Maybe we'll use H for high school, etc. So we want to look at some of these probabilities and see if we can put into words what they mean. I mean, okay, it's great that this number is 0.5450. What's that mean? How would you go to someone on the street, basically, and explain it to them? You wouldn't just go and say, here's my data. Look, isn't it pretty? So let's talk about what they mean. So probability of C equals 0.1504. And y'all have space to write on the top of the next page. Because I know this one's kind of at the bottom. So if you want more space, there's like a huge blank space on the top of the next page to write these. Because we'll actually need these numbers on our examples. Okay, so what does this mean? What does that proportion stand for? The proportion of teachers who teach college. So these are all teachers over here. This 0.1504 is the proportion of teachers who are college teachers. That's what that stands for. Okay, let's look at another. Probability of C and S, or C intersect S, equals 0.0951. What does that number tell me?
The proportion of college teachers who are satisfied.
That's perfect. The proportion of, no, almost. The proportion of teachers who are college teachers and who are satisfied. So we can't say of college teachers because it's still a proportion of the whole teachers.
Let's just satisfy college. Right?
Yeah. Teachers who teach college and are satisfied.
What is the difference between that upside down U and the little line that you put in the other ones?
So the upside down U, like, are you talking about what's the difference between this and the line?
Yeah, where you just like put a vertical line down the middle.
The vertical line means given. So that tells you it's conditional probability. That means the probability of, if we're using this example, college given satisfied. So that given tells us essentially we can cut out the rest of this table since since we're told that it's satisfied. Now these are the only numbers that matter. This upside down U is the intersection of college and satisfied. So it's where college and satisfied intersect, which is right here. Does that make sense? Okay, what does this tell us? The proportion of teachers who are satisfied with their job. Perfect. Okay, questions on like putting this into words? No? Okay, so then let's look at an example. We want to find the proportion of teachers who are college teachers given that they are satisfied. Which symbol means given? Yeah, the vertical line, that's right. So how would you put this into symbols? How would you put this statement into symbols? I'm going to give you the P. What would you put inside the parentheses beside the P?
The C, the line, and S.
C, line, and then S. That's right. Probability of college given satisfied. Okay, if we just write the formula first, we're not going to plug numbers in yet. Let's nail our formula down first. What would go on top? Inside the parentheses. C and S. So probability of C and S over the probability of S. Good. The upside down U means and. The U itself means or. So this means and. If it was flipped, that would mean or. So what's this top number going to be? What's the probability of our intersection here? 0.0951. What's the probability of total satisfied? 0.5450. So that's our numerator and our denominator. And that's equal to what to 4 decimal places? .1745. That's right.
Schultz,
Yes.
is this next complaint, or this next question, is the last time we're going? Right.
And then I want y'all to try one from your homework, but I'm gonna tell y'all which one I want y'all to try. From the one that's due on Friday, so the one I just gave you. Okay, so how can we put this into words? What does this mean? What is this proportion?
The proportion of college teachers who are satisfied.
Quotes. It's the proportion of satisfied that are college teachers. Our total is of satisfied. So it's the proportion that they're satisfied. I just said that backwards. It's the proportion of the satisfied who are college teachers. Yeah. We can't flip it because then what you were saying, Olivia, would be talking about this row. Does that make sense? Yeah. So we gotta be really specific when we talk about these. This gives us the proportion of satisfied that are college teachers. Yeah, I want y'all to start trying to work on that last example. See if you can figure out that probability. So the last one, set it up and try to get the probability. What you got? We can't do that yet. First, we need our bar. So, satisfied given.
Given is that, my bad. That's
Yep.
And then how late?
Get which one?
That's an intersection, right?
Intersection of S and C.
That's the same one. Okay. All right, thank you.
Is it one? Which one comes first? Satisfied, given college.
So you have to go by the order?
What'd you
Yes, you go by order. Yes. S given C. Is it not C over S?
So the ones that are certified, they have color.
Yeah, going for it.
Yep. So you do the intersection.
But it would still be that one, right?
Yes.
And then it'd be
Yep,
over
over.
the total of satisfied? Would be zero.
Oh, it's our second one in the parentheses.
Oh, so it'd be zero.
College, so probability of college.
I didn't know you had to go.
Oh, yeah. Order is really important. That's actually the reason we're doing both of these, to show the importance of order.
So, you have satisfied given college. line C.
Uh-huh.
I'll tell you, and then you put, don't tell me that.
This is our feature.
You put the school first line. Okay.
No, on top is the intersection. The word dissatisfied intersect column.
Right here. What is it on there? Like this one on top. And then, college, and then the first one wrong. And then you get to that.
Put it, make sure you put that in the right. Okay, so it looks like several of y'all have gotten the right answer. What'd y'all get? Someone that I haven't checked yet. What'd you get?
0.6323.
That's right. So order is important here. I'll set it over there. Order is important. They say satisfied given college. That's the order you need to put it in. Now, when you have an intersection, you can switch them around and it would still be the same. If it's just intersect, that's still the intersection of the two. I mean, whether you come from satisfied first and then college, or college then satisfied. Intersection-wise, we can switch them around like that. But for conditional probability, if you notice, we did C and S, but look at how different our numbers are. This one is 0.63, the other was 0.17. So how can I put this one into words? What is this the proportion of?
Proportion of college teachers are satisfied.
Proportion of college teachers, the other satisfied, that's right. Are you talking about word-wise?
No?
The first one was the proportion of satisfied that were college teachers. This one is the proportion of college teachers that are satisfied.
No, it's opposite. I think so the first one is college teachers that are satisfied. It's this one is satisfied college teachers. You said it after. I think, no?
Okay, let's see. Which one's on bottom here? So this is our total, so it's the proportion of college teachers that are satisfied. This one. This is the proportion of college teachers that are satisfied.
Oh. I thought you were talking about the word.
No, you're not.
Satisfied college teachers.
Yes, proportion of college teachers who are satisfied. Yes. That's
Where
what I
is
was
this homework due?
probably. But the one I just figured out today?
Is this one after one?
Yes.
Oh.
That's all I was gonna have. Okay, so dual credit, the homework that I passed out today, this is it as far as notes go. But number 5 on the homework I passed out today uses this. So if you wanna figure out if you understand it or not, try number 5. Okay, what you got? I thought you were
Yeah, I'm not really.
Yes. I'll be here physically, but I'm doing virtual tutoring. So I can't have in-person people in the room doing virtual tutoring.
Like, come in and leave before 4.
If you come in before 4,
I did.
question?
So, this one says, let's see.
Sorry. That way there's not a bunch of extra stuff at the end of the video.